Hello, good afternoon. Good afternoon to everyone. I hope you all are able to see my screen and I hope you all are able to clearly listen my voice. I hope I'm audible. Okay, just those who are watching, please just confirm. Then we will start our discussion of last test. Okay, so just all of you please join. Okay. Okay, everything looks great. I think most of you joined. So how was the test? Chemical kinetics test. I hope all of you attempted it and all of you did well, I think. Okay, so let's start now. So in this session we are going to discuss today's paper of chemical kinetics. There were two separate papers for JEE and NEET. So we will discuss some most important questions of today's test in both JEE and NEET papers. Okay, so I think we should start now. All of you, please join. Yeah, all set. Done. Chalo. Let's start. So today's topic is we will discuss the test paper of chemical kinetics, mock test paper that happened today. So let's start with the discussion, and we have some most important questions of today's test. So we will start now. Okay. So coming to our first question. So first we are discussing the JEE paper. So in JEE paper, the question number 1 that says, which among the following statement defines molecularity? So I hope all of you are aware of what is molecularity and what is order of reaction. So we all know what is molecularity. It is the number of reactant molecule participating, colloiding with each other to form product. That is the molecularity of reaction. Now we have to read the all four options, then we will decide which is the correct answer. Okay, so let's start with option number A. So what is the option number A? What option number says is, option number A is molecularity of a simple reaction is equal to the sum of number of molecules of reactions involved in a balanced chemical reaction. So this is the molecularity of simple reaction is equal to sum of number of molecules of reactions. It is not reactions, it is reactant basically. So you can correct it. It is reactants. So I think this statement is correct. Molecularity क्या होती है? That is the sum of number of molecules of reactants involved in a balanced stoichiometric reaction. So I think this option is correct. Now coming to option number B, what it says that the molecularity of a reaction is the number of reactant molecules taking part in a single step of a reaction. That is also correct for a complex reaction, because complex reaction is made up of multi steps, or we can say multi-step elementary reactions. So for a elementary reaction or for a single step reaction, it is simply the number of reactant molecules taking part. So this is also correct. Now coming to the third one, that is the minimum number of reacting particles that come together or colloid in a state determining step to form product or products is called molecularity of the reaction. As I already told you what is molecularity, and this is the exact definition of molecularity, that means this option C is also correct. So our answer will be D, all of the above. I hope this question is clear to all of you. Anyone, any doubt in this question? They can clearly ask in the chat section of YouTube or in Zoom. Okay, so moving forward. Now coming to next question. Our next question says, let's see. We have taken question number 3, that is graphical question. We all know that there are many graphical questions that is being asked in JEE Mains for chemical kinetics chapter. Now let's start with this question number 3. What it says that the graph between T half, that means half-life versus concentration of a second order chemical reaction. So we all know that the relation between half-life T half and any reaction of any order, that is T half, is directly proportional to 1 by A naught to the power of n minus 1. N minus 1. We all know that T half is directly proportional to 1 by A naught to the power n minus 1. According to this relation, we can decide the relation between half-life and initial concentration of any reaction, any order reaction. Now coming to the, we have to calculate the second order reaction. For second order reaction, if we put n equal to 2, so it will become T half is inversely proportional to 1 by A naught. T half is inversely proportional to initial concentration for a second order reaction. We all know that. So let's check the options. Now in first option, you can clearly see that T half is directly proportional to the concentration. We can clearly see that in first option, T half is directly proportional to initial concentration. I think that is not correct. Is that clear? Because we have already seen T half is inversely proportional to initial concentration. So option A is incorrect. Now coming to option B. What is this option B? Option B, you can see here, this is not representing T half is inversely proportional to A naught. So this is also incorrect. Now coming to option C, here T half is already constant. So we all know that this is also not correct. Now coming to option number D, here you can clearly see that T half and concentration are inversely proportional. So therefore, our answer will be option number D, because it represents half-life of second order reaction is inversely proportional to initial concentration. That means option D is the correct option. Is that clear to all of you? I hope question number 3 is clear to all of you. Anyone any doubt in this question? They can clearly ask. Okay, cool. Now next, moving to next question. So we have taken 2 more questions here of JEE exam that is happens today. So what is this question is? Now here you can see this question number 6. The thermal decomposition of gaseous ammonia on platinum is an example of zero order reaction. So here we have given with a zero order reaction. Okay, on plotting the concentration of ammonia with respect to time, a straight line is obtained with slope equal to. So we have to calculate the slope of a zero order reaction. Okay, so first we know that integrated rate equation of zero order reaction is AT equal to A naught minus KT. That we all know for a zero order reaction. For a zero order reaction, the integrated rate equation is AT equal to A naught minus KT. Now, what we have to find out? We have to find out the slope of concentration versus time. So we have to plot the slope, plot a graph of AT versus T. Now compare it with y equal to mx plus c. So y equal to c plus mx. On comparing these two equations, we can clearly see that m is equal to minus k, and in this equation what m represents is slope of the straight line. So here we can get the slope of straight line that is plotted between concentration of ammonia with respect to time. Therefore m will be equal to minus k. Hence option C is correct. I hope this question is clear to all of you. Okay, now moving to next question, question number 7. In question number 7, it is written that the rate constant for a reaction. So first we have given with a rate constant, that means we have given with K. What is the value of K here? It's 2 into 10 to power minus 4 liter mole inverse second inverse. Now from the unit of K, we can decide this is nothing but a second order reaction. Is that clear? We all know that we have to calculate the order of reaction by seeing the rate constant unit. So here it is second order reaction. We can clearly see from the rate constant unit. Okay. Now the concentration of A at which rate of reaction is this much. So we have to calculate that concentration at which rate becomes this much. Now, for a second order reaction, we all know that rate equal to K concentration of A to the power 2. Now put the value of this rate. Rate is nothing but here 1 by 12 into 10 to the power minus 5, and also K is given 2 into 10 to the power minus 4 into A square. Now we can clearly find out what is the value of A here. So we can solve it and we can get the answer like you can clearly solve it and get the answer as initial concentration of A is equal to 1 by 20 under root of 5 by 3 molar. Is that clear? So in this question, what we have to do is we have to find the value of order of reaction. Is that clear? Okay. Moving to our next question, next important question, that is question number 9. So here you can see clearly this is an example of parallel reaction. I think you all are familiar with what is consecutive and parallel reactions. So this is an example of parallel reaction. How we can decide? Because you can clearly see that A is the single reactant and it is giving two different products like B and C with two different rate constant K1 or K2. Now, what we have to calculate is percentage distribution of B and C. So for that type of reaction, for that type of parallel reactions, what you have to remember is first you have to know the formula of concentration of B by concentration of C is nothing but it is equal to K1 by K2. This is the most important formula you should remember for solving a parallel reaction. Now what we have to calculate? We have to calculate the percentage of B. So for that percentage of B, formula will be K1 by K1 plus K2 into 100. K1 by K1 plus K2 into 100. That is the simple for calculation of percentage of B. Now here you can see what is K. 1 into 10 to the power minus 4, that is only 10 to the power minus 4 we can write, and here K2 is K1 plus K2 will become 10 to the power minus 4 plus 5 into 10 to the power minus 5 into 100, and upon solving this calculation we can get the answer as for percentage composition of B, that will be, we can calculate it and we will get 66.67%. Now, if we are getting percentage of B is 66.67%, so we can clearly calculate the percentage of C, that is 100 minus percentage of B, that is 66.67. So we will get around 33.33%. So our answer will be answer number A, that is representing the percentage of B and percentage of C in a series type reaction that is given here. Is that clear? So that is very much important questions for solving series and parallel type kinetics. I hope you all got this answer. I hope any doubt, anyone, you can clearly ask this question. Now coming to next one. So this is also important graphical questions for chemical kinetics. You can see here, consider the plots for the types of reaction. Okay, we have to consider the plot. We have given with 3 plots, first, second, and third. What we have to calculate is we have to calculate the value of x plus z minus y, and what x, y, z are representing. These are nothing but the order of reactions with these plots. So for first plot, order is x, for second order is y, and for third order is z. Now on seeing this graph, we can clearly define the order of reaction. Okay, now coming to first graph. First graph, what it is showing, that it is showing minus dA by dt is directly proportional to initial concentration. Concentration. So you can clearly see that rate of reaction is directly proportional to the concentration. That means this is nothing but it is a first order reaction. That means X equal to 1. Clear? Now coming to our second reaction. In that case, you can clearly see that our initial concentration is decreasing with respect to time and it is showing a straight line. So we can clearly see that it is second order. So that means y equal to 2 we get. Now, oh sorry, it's initial concentration is decreasing with respect to time. No, it's not 2. It's 0. It's 0 because we all know that. Just let me erase it. Just give me 1 minute. It's not 2 because here you can clearly see it is showing a straight line and we know that for zero order reaction AT equal to A naught minus KT. If we plot this equation, then we will get this type of, that means y equal to 0. It is representing a zero order reaction. Now coming to number third graph, we all know that 1 by AT equal to 1 by A naught plus KT. Is that clear? So we all know that this is representing a second order graph. That means here Z is equal to 2. Now what we have to calculate? We have to calculate X plus Z minus Y. Here we know that X is 1 plus Z is 2 minus Y is 0. We will get answer as 3. So this is basically a integer type question in which we have to exactly calculate the numerical value, and this question answer is 3. We have to calculate X plus Z minus Y, and that is 3 only. Is that clear? Anyone, any doubt in this question? Okay, cool. Now coming to next question. This is the last question of our exam. So let's start. This question is saying the first order gaseous decomposition of N2O4 and NO2. So we have given with first order decomposition of N2O4 and NO2 has a rate constant value K equal to 4.5 into 10 to the power minus 3. So first write it K1 equal to 4.5 into 10 to the power minus 3. Why we are writing K1? Because here it is given with 2 Ks. So first is K1 and second will be K2. K2 is 1 into 10 to the power 4 second inverse. Now what we have to calculate? What should be the rise in temperature in degrees Celsius to get the value of K this? So first K is given 4.5 into 10 to the power 3, and we have to increase the temperature to make the value of K as 10 to the power 4 second inverse. So we all know that the relation between rate constant and temperature formula. What this formula is? Log of K2 by K1 equal to EA by 2.303 R 1 by T1 minus 1 by T2. That we all know. We have already discussed about this formula. Now put all these values and get the value of T2. So log of here K2 is 4.5 into 10 to the power 3 by K1 is 1 into 10 to the power 4 equal to, and we are given with EA or not, just check here. Yeah, activation energy is also given 58 kilojoule. 58 into 10 to the power 3 kilojoules. We have to convert it into joules. 2.303, and R value we all know that 8.314. 1 by T1. What is T1? 1 degree Celsius. That means 274 minus 1 by T2. That we have to calculate the value of T2. Is that clear? Now on solving this equation, we can clearly get the value of T2. On solving, we will get T2 as 283 Kelvin. You all can solve this equation and you will get the value of T2 as 283 Kelvin. 283 Kelvin, we can represent it like that, 10 degrees Celsius. So our T2 temperature is 10 degrees Celsius. So we have to make temperature from 1 degree Celsius to 10 degrees Celsius to make new constant K equal to 10 to the power 4 second inverse. But see here, what question is asking that what should be the rise in temperature? We don't want to give the answer as T2 equal to 10 degrees Celsius. We have to calculate the rise in temperature. Temperature में कितना increment हुआ है, that we have to calculate. That means we have to calculate T2 minus T1. T2 is 10, T1 is 1. Answer is 9 degrees Celsius. So you have to give the answer as 9 degrees Celsius, not 10 degrees Celsius. That is the most common mistake. Is that clear? Anyone, any doubt? So I hope I have covered all the important questions of JEE exam. These are some most important questions. Anyone, any doubt? Any other question? In JEE exam, any students have doubt in any other question? They can clearly ask now. Okay, no issue. So we will start with paper discussion of NEET paper. Someone is writing something. Okay, no. Okay. So moving to our NEET section. I hope all of you attempted these questions. Okay, cool. Next, moving forward to NEET section. So in NEET sections also we have taken some important questions that we are going to discuss here. Okay, now start with our question number 1. What this question is saying, all of you just read it and try to give the answer. Okay, so in this question it is given that the time required for 100% completion of a zero order reaction. So that is very simple question that we all know. We have to calculate the 100% completion time for zero order reaction. Okay, let's start. See here, we all know that for a zero order reaction, AT equal to A naught minus KT. That we all know. AT equal to A naught minus KT. Now we have to calculate time 100% completion. That means when reaction is 100% completed, the final concentration becomes 0. So AT will become 0. And initial concentration we can write it A naught minus K, and T here is T 100%. Now you can clearly see that A naught equal to K T 100%. So here we can get T 100% equal to A naught by K. So this is the answer. Time required for 100% completion is A naught by K. I hope you all got this answer. And we have already derived the half-life of zero order reaction, that comes T half equal to A naught by 2K. But here we are deriving the T 100%, that is A naught by K. It's not A naught by 2K. So we will get answer like A naught by K. Here A naught is taking as small a. So answer will be option number C. Option C, A by K is the correct answer. Clear? Anyone any doubt in this question? Okay, cool. Now coming to second most important question. Now see here, for one reaction is given, 2N2O5 gives 4NO2 plus O2. Rate and rate constant are given. We have given with rate of reaction and also with rate constant. Okay, so we have given with rate constant and rate of reaction. We have to calculate the concentration of N2O5 at the same time will be. So we have to calculate the concentration. Now here it is not given what kinetics this reaction is following. So by seeing the unit of rate constant, we can clearly decide the order of reaction. Now here you can see rate constant is 3.4 into 10 to the power minus 5 second inverse. So you can clearly see that rate constant unit is second inverse. K is given 3.4 into 10 to the power minus 5 second inverse. So what will be the order of reaction? Anyone can answer this question? Very simple question. We have to you have to give the answer of order of reaction of this reaction. Okay, cool. So we know that its rate constant is second inverse. So definitely it will be first order reaction. Is that clear? Now we get the order of reaction. Only we have to calculate the concentration of N2O5. So for that we all know that rate of reaction equal to K concentration की power 1. So we have to calculate concentration of N2O5. In place of A, we can write it N2O5. So we have to calculate this N2O5 concentration. So N2O5 concentration is nothing but rate of reaction by K. Now you can solve this question. The rate of reaction is 1.02 into 10 to the power minus 4. 1.02 into 10 to the power minus 4 divided by what is rate constant, that is 3.4 into 10 to the power minus 5. 3.4 into 10 to the power minus 5. Now you all can solve this question and you will get the answer as approximately 3. Is that clear? Anyone in doubt? So we get the answer as 3. Now check the answers. The concentration of N2O5 at the same time will be, that is 3 only. Is that clear? Anyone in this question, in these two questions, anyone any doubt? You can clearly ask in the chat section or chat section of Zoom also. In YouTube, you can also ask the question. Okay. Okay. Next. Coming to our next questions. Oh, this type of question is very important for NEET and JEE purpose. That is basically we have to calculate the order of reaction by reaction mechanisms. We have different types of approach to calculate the order of reaction. In this one is the most important and frequently asked questions. Okay, let's start now. So in question number 6, mechanism of a hypothetical reaction. We have given with a hypothetical reaction. What is this reaction is? X2 plus Y2 will give 2XY is given below. So one reaction is given, X2 plus Y2 gives 2XY, and the reaction mechanism of the above reaction is also given. Now first write this reaction. Reaction is X2 plus Y2 will give 2XY. Now write the rate expression for this reaction. So we all know that rate of reaction equals to K X to the power something X Y to the power Y, because we don't know this one is elementary or complex reaction, so we have to take stoichiometric coefficient as X and Y. Now we have to calculate the order of reaction. That means order of reaction here is this X plus Y. Now first we have to calculate the value of this X plus Y. Now coming to mechanism of the reaction. Now you can clearly see that we all know that slow step is the rate determining step. So we have to deal with only RDS, a rate determining step. And what is this? X plus Y2 will give XY plus Y. So by this reaction, we can calculate rate of reaction equal to K X Y2. Now we get Y2 to power 1, that means Y ki value is 1. But we have to deal with value of X here. Now for that reason, we have to take this reaction. Here it will be equilibrium. So we all know that K equilibrium in this reaction will be equal to X into X by X2. Is that clear? From this equation, we can get the value of this X, and this X will be under root of K equilibrium into X2, or we can write it like that: K equilibrium to power half into X2 to power half. Is it clear? This is the value of X. Now put this value of X into this equation. So we can get K into X is K equilibrium to power half. Okay. And H to power half and Y to power 1. Now this K into K equilibrium to power half is also 1K, constant only. Constant into constant will give the constant value only. So we will get X to the power half, Y to the power 1. That means X equal to half, Y equal to 1. That means order of reaction will be half plus 1, that is 3/2. That means it is 1.5. So our answer will be answer number C. The order of the above reaction is 1.5. Is that clear? So in that type of questions, we have to deal with a rate determining step, slow step. We have to check the rate of reaction of slow step. Is that clear? What we have done? Just see here. First, we have given with this equation x2 plus y2 will give 2xy. We have written the rate expression for this equation. And then we have started with rate determining step, slow step. That is x plus y2 gives xy plus y. And we have also written the rate expression for this slow step. But it is in the form of x. But we have to find the rate of reaction in the form of x2. So for that reason, we calculate the value of x in terms of x2. And putting this value of x into this equation, we will get rate of reaction in terms of x2 and y2. And in terms of x2 and y2, we will get the value of x and y, that is x is half and y is 1. Order of reaction is half plus 1, that is 1.5. Is that clear? I hope this question is clear to all of you. Anyone any doubt? Okay, so that is very much important question. Okay, na? Now coming to our next question. So this is very easy question. Very easy question, and this type of questions are frequently asked in this NEET. Okay, dhyan rakhna. Let's see. This question is: a first order reaction has a specific rate. Here we have a specific reaction rate 10 to power minus 2 second inverse. Is it clear? Now, how much time will it take for 20 gram of reactant to reduce to 5 grams? So 20 gram of reactant, we have to reduce it to 5 gram. Now, you can clearly see we have given with K equal to 10 to power minus 2 second inverse. So for that type of questions, we have two methods. First, we can directly apply the integrated rate equation for first order reaction, or we can use half-life of reaction to calculate the time. Is that clear? Now see, let's start with the first approach. First approach is nothing but KT equal to 2.303 log of A0 by AT. First method is this. We can put all these values K, A0, AT, and we can get the T. But second step is we have to reduce it 20 to 5 grams. 20 to 5 grams. So for reducing a reactant from 20 gram to 5 grams, first we have to reduce it 20 to 10. It will take 1 T half. And again 10 to 5, it will take another 1 T half. So that means for reducing this reactant from 20 gram to 5 gram, we require 2 T half. Is that clear? So that is the main funda. For 20, from 20 to 5 grams, it consumes 2 half lives. So time is 2 T half. Now we all know that how to calculate T half. T half is 0.693 by K, and K is given 10 to the power minus 2. Is that clear? On solving, we will get the answer as 138.6 seconds. 138.6 seconds we will get answer. Answer is our A. I hope this question is clear to all of you. It is very simple approach to attempt first order reaction questions. Anyone, any question? Anyone, any doubt in this type of question? I think It is clear to all of you? Okay, cool. Chalo. Moving forward, coming to our next question. Okay. So this next question is question number 12. For the reaction 3A plus 2B gives C plus D. Here we have given with one reaction and we have to calculate the, we have to find the differential rate law. Okay. So we have to find the differential rate law for this reaction. Okay. Let's start with the reaction 2A plus 3B. It's 3A plus 2B. Okay. 3A plus 2B gives C plus D. Now for that we can write the differential rate law equation is minus dA by 3 dt, that we all know, equal to minus dB by 2 dt because these are reactants, equal to dC by 1 dt equal to dd by 1 dt also equal to K A to the power x B to the power y, that we all know. Clear? Now check the options. Check the options, or we can write in place of xy, we can write n or m. No need to confuse. Okay, let's see. So in this question, first one, option number 1, here negative is not mentioned, minus is not mentioned, that means this is incorrect. Here minus dA by dt only, it should be 3 dt, this is also incorrect. Here it is plus, incorrect, that means option number D is the correct answer. You can check here, minus 1 by 3 dA by dt equal to plus dC by dt equal to K A to the power n B to the power m. I hope this question is clear. Very simple question. How many of you attempted this question? Okay, cool. So coming to our question number 13, that is also based on RDS equation question. Okay. Now see, just read this question. Approximately, what is the activation energy for a reaction if its rate doubles when temperature is raised from 20 to 35 degrees Celsius? So first, temperature is raising from 20 degrees Celsius to 35 degrees Celsius. We have to calculate activation energy. Okay, so let's start. Suppose at T1 is given, that is 20 degrees Celsius. 20 degrees Celsius, that means 293 Kelvin. And is T2 is given, that is 35 degrees Celsius. That means it will be 308 Kelvin. Now K2 is 2 Kelvin, that is given. You can clearly see here that we have to calculate the activation energy when rate doubles. That means K2 will become 2 K1. Now we know that the formula log of K2 by K1 equal to EA by 2.303 R 1 by T1 minus 1 by T2. Now we can solve this equation and we will get the value of activation energy EA. Putting all these values, log of K2 by K1. K2 by K1 is nothing but it's 2. Log 2 equal to EA by 2.303. R is 8.314 joule per mole Kelvin. 1 by T1 is 293 minus T2 is 308. On solving this equation, we will get EA equal to, on solving this equation, we will get EA equal to 3.5 into 10 to the power 4 joule per mole. On converting it into kilojoules, we will get 35 kilojoule per mole. You all can solve this equation. Just solve this equation, then you will get the value of EA as 35 kilojoule per mole. Is that clear? Anyone, any doubt? I hope this question is clear to all of you. Okay, let's check the options. So we have given with 34.7. Approximately this is the correct answer because we have got answer approximately 35 kilojoule per mole. Is that clear? Anyone? Any doubt in this question? ठीक है, बढ़िया. So again, moving to next question. Okay, so this is also one method to calculate the order of reaction by experimental data. We have already learned about how to calculate order of reaction. It can be calculated theoretically, or it also can be calculated by reaction mechanism method, otherwise experimental data method. Is that clear? Now we have to calculate the order of reaction and we have to write the rate law for the above reaction. Now see here, we have given with A plus B gives product. Now for that we can write rate of reaction equal to K A to the power X concentration of B to the power Y. Now we are given with three experiment. Experiment number 1, our rate is 2. Okay, we can put rate as 2, K is K, A is 0.2, 0.2 per X, and B is 0.2 per Y. Equation 1. Now coming to experiment number 2, rate is 4. At that time, A is 0.2, B is 0.4. Now experiment number 3, rate is 36. K, A is 0.6, B is 0.4. Now we have three equations. We can solve these three equations and we will get the value of X and Y. How to solve these equations? Now equation 1 divided by equation 2. You can see here 2 by 4 equal to, you can see K to K cancel hoga, 0.2 per X will be cancelled out by 0.2 per X, only it will be 0.2 by 0.4 per Y. On solving it, 1 by 2 equal to 1 by 2 to power Y. That means it is very clear Y equal to 1. So we get the value of Y as 1. Now next we have to calculate value of X. So for calculating value of X, we can do equation 2 divided by equation 3. Let's start now. 4 by 36. K is cancelled out and 0.4 to power Y, 0.4 to power Y we cancel out. And it is 0.2 by 0.6 to power 1 by power X. Now again solving this equation, it is 1 by 9 equal to 1 by 3 to power X. That is very clear, X equal to 2. Because we know that on squaring 1 by 3 we will get the value of 1 by 9. So we will get the values of X equal to 2 and Y equal to 1. Order of reaction X plus Y, that means 2 plus 1, that is equal to 3. So order of this reaction is 3 and X is 2 and Y is 1. Now checking the options. So just check, X is 2 and Y is 1. So option is our option number D. Here you can clearly see that R equal to K, A to the power 2 and B to the power 1. That means our option number D is the correct answer. I hope this question is clear to all of you. These type of questions are given in NCERT also. Clear, eh? Okay, cool. So coming to our next question, question number 26. This is also molecularity based question that we have already discussed in JEE paper. Okay, let's start now. Question number 26. Consider the following statements. Here we have given with three statements A, B, and C, and we have to check which of the following is correct statement. Clear? Now see, 26 may statement 1 is saying that molecularity of a reaction can be 0. Molecularity of a reaction can be 0. We all know that molecularity can never be 0. order of reaction can be 0, but for a reaction to proceed, there should be at least one molecule will be present to collide. Otherwise, reaction will not happen. That means molecularity of a reaction cannot be 0. So that means statement A is incorrect. Now, order of reaction can be fractional, that we have already seen many examples. In many examples, order of reaction is fractional. In the last question, I think we have seen order of reaction as 1.5 or 3 by 2. So that can be possible. That means this is correct statement. Now, number C, molecularity is not defined for a chemical reaction. Molecularity is not defined for a chemical reaction. So I think for a complex reaction, okay, for a complex reaction, that is also correct option. We cannot decide molecularity for a chemical, for a complex reaction. Molecularity is decided only for the elementary reactions. Okay, so therefore our answer will be answer number B. A only. We have to choose the incorrect options only. Clear? Okay. So now starting with next question, that is also graph based questions for Arrhenius equation. So we have to check the correct plot of Arrhenius equation. So we all know that Arrhenius equation is K equal to A e to the power minus EA by RT. But here we have given with ln K versus 1 by T graphs. So first take log or ln. So it will be ln K equal to ln A e to the power minus EA by RT. Is that clear? Now it will be ln K equal to ln A plus ln e to the power minus EA by RT. On solving again, ln K equal to ln A plus minus EA by RT, or we all know that ln E is 1. We get the final equation ln K equal to ln A minus EA by RT. Now comparing this equation, y equal to C plus mx. When we compare this equation, we get a straight line for ln K versus 1 by T graph with slope equal to minus EA by R and with C intercept equal to ln A. So just take, we will get a straight line with negative slope. So we can clearly see here that this is positive slope, this is positive slope, this one is positive slope. In this case, intercept is 0. That means only in option number A, we are getting a straight line with negative slope and intercept ln A. Here slope m equal to minus A by R. Is that clear? So for that, what we have to do, first we have to take log of this Arrhenius equation, and then we will get a equation, and on combining this equation with a straight line equation y equal to mx plus c, we get a straight line graph between ln K versus 1 by T, which is having slope equal to minus EA by R and intercept equal to ln A. On comparing this data with the options, we will get the answer as option number A. So this is also a very much important questions. Is that clear? Anyone, any doubt? Okay. Now coming to our next question or last question. So that is also depend upon the parallel reaction. Here we can clearly see that A is producing different types of products, A1, A2, A3 up to AN with different rate constant also. For A1 it is K, for A2 it is 2K, for A3 it is 3K. So we have given with a parallel reaction. Clear? And we have to calculate minus dA by dt. Now see, if we can clearly see here is, let's see, first taking reaction A2, A1, then we'll see A2, A2, then we will see A2, AN. rate constant K, 2K, Nk. Now here you can see minus dA by dt equal to K into A. Here minus dA by dt equal to 2 into A. Here minus dA by dt equal to Nk into A. It's not 2A, it's just give me a minute. It's 2K into A. So we can clearly see that in all steps of this reaction, we are getting rate equation like that. Now, on adding all these equations, what we will get, just see here, final minus dA by dt, that is equal to, you can clearly see, Ka plus 2Ka plus 3Ka up to Nka. So we will get this equation. Now, again, solving this equation further, dA by dt equal to, we can clearly see here, it is 1 plus 2 plus 3 plus 4 up to N K into A. So we are getting here a series 1 plus 2 plus 3 plus N. And we all know that the sum of this series is N into N plus 1 by 2. If we add this series, we will get N into N plus 1 by 2 into K into A. So this is the overall rate equation minus dA by dt equal to N into N plus 1 by 2 K into A. Is that clear? So this is our correct answer. Now checking with the options. Just check with the options. So what will be the answer? Answer is option number A is not correct. B is the correct answer. Here you can clearly see N into N plus 1 by 2 K into A. Is that clear? Very interesting question that was. I think all questions are clear to all of you. If any question, any doubt, you can clearly ask me in the Zoom chat section or also in YouTube chat section. Okay. So I hope you enjoyed today's class, and I hope you all have attempted all the questions. Okay, cool. Okay, then see you in the next class. Thank you.